In this case, we are interested in the calculation of current in 5 ohm resistance. Now recall the steps which we have discussed in case of the Thevenin theorem. What is the first step? First step is remove the load resistance and redraw the same circuit. Is it right? So here in this case, we are removing the load resistance and redrawing the same circuit. Suppose this is the A terminal and this is the B terminal. Is it right? Now we are removing the load resistance and redrawing the same circuit. I will write the same. Redrawing the same circuit. Is it right? Now here, if we are removing the load resistance and redrawing the same circuit will be something like this. Here will be the 2 ohm resistance. This is the 8 ohm. This current is 1.5 ampere as it is. This is the 6 ohm as it is. This terminal will be the A terminal. And then this will be the 30 volt source. And this next terminal will be the B terminal. It is 6 ohm. This is 8 ohm. This current is 1.5 amperes. Is right. This is the 2 ohm resistance. It is the 30 volt source. At the same time, we have this is another resistance, which is the 4 ohm resistance. Is right. This is the 4 ohm resistance. What we have done? We have redrawn the same circuit. Now, our aim is the calculation of voltage between these 2 points. Our aim is the calculation of voltage between the 2 points. Is it right? Yeah. So here in this case, if we are interested in the calculation of the voltage between the 2 points, we have to calculate current in this loop or this loop. Use any method. Here we cannot use the direct inspection method because here is the current source. We can use the direct inspection method only when we have only sources as voltage source. So here we can use the super mesh. This is 1, 2, 3 loop super mesh we can use, or we can use the nodal analysis. This is node 1, this is node 2, this is node 3. In that case, we have to shift this potential to its nearest node by assuming this as the ground potential. Use any method. Here I will prefer the mesh analysis. This is loop 1, its current is I1. This is loop 2, its current is I2. And finally, this is the loop 3, its current is I3. Is it right? I1, I2, I3. In this case, what I will do, just I will discuss and then we will proceed. In this case, I will apply the KVL to this first loop, as well as we are not in a position to apply the KVL to the second loop, or we are not in a position to apply the KVL to the third loop. Is it right? In place of that, I will assume this as a super mesh. Is it right? This as a super mesh. This is outer branch as a super mesh. Otherwise, I will give the name here. This may be the A, B, this is C, this is D, this is E, F, and G. This is the names I have given. We will apply the KVL to that super mesh and we will find out its equation. I will write first applying the KVL to the first loop. First mark the terminals. Here this will be the plus, this is minus, this is plus and minus again, this is plus and minus again. Same is for the loop 2, and we are applying the same thing for the loop 3. Is right. I will write first applying the KVL to loop 1. Applying KVL to loop 1. If we are applying the KVL, that is Kirchhoff's voltage law, to the first loop, how will be the equation? If we are applying the KVL to this loop, we will start from this point. We will travel in the clockwise, negative to positive, which is a plus. Its voltage is 30 volt. Then positive to negative, which is minus, resistance is a 2, and its current will be I1 minus I3. Is it right? Then we'll come down positive to negative, which is minus, its resistance is 8 and its current will be is I1 minus I2, which is equal to 0. This is the KVL for loop number 1. Are you getting me? Anyone has any difficulty, please raise your hand. I will clarify your doubt. Akash?
No, sir, no difficulty.
No difficulty. Yeah. So here in this case, if we are simplifying this equation, this will be 30 minus 2I1 minus of minus plus, it is 2 into I3 minus it is 8 into I1 plus it is 8 into I2, which is equal to 0. If we are simplifying this equation, this will be minus 8 and 2, that is 10. 10 I1 plus, this is 8 I2. 8 I2, is it right? Then plus 2 I3, which is equal to, I guess it is minus 30. This is the equation number 1. Is it right? Just we are simplifying this equation. Now here, I will discuss here applying KVL to super mesh. Which is the super mesh? This complete. A, B, C, D, E, F, G, and A. The super mesh. We are applying the KVL to the super mesh. Consider any part as a super mesh, which should not have this branch. Super mesh may be this. Means here, super mesh may be this inner point. This is B, C, D, E, F, G, and this point. Or maybe something like that. This is super mesh. Is it right? If we are starting from this point again for super mesh, we are traveling from the negative to positive plus, its voltage is 30. Then I am traveling positive to negative, which is minus 4 into its current, that is I3. Then we are coming back positive to negative, which is minus 6 into its current, which is I2. Then we are coming back. There is no element which is equal to 0. This is right. This here, in this case, equation will be minus 6I2 minus 4I3, which is equal to minus 30, or 6I2 plus 4I3, which is equal to 30. This is equation number 2. How many equations we need? We need the 3 equations because we have the 3 loops. Is it right? So here in this case, now third equation we are calculating for this current source branch or applying the KCL at this particular point. But I will write from the current source branch. From current source branch we get, what we get from the current source branch? This is 1.5 ampere. Forward current is 1.5 ampere. Is it right? Now in this branch we have the 2 currents, I2 and I3. Now look at this is forward, this is forward. That's why I2 will be the positive, then minus I3. This current in this branch will be I2 minus I1 or I3 minus I2. Is it right? But it is forward, that's why I2 will be positive, this will be the negative, and the resultant value will be this. Is it right? Otherwise, we have the equation as something like this. It is I2 minus I3, which is equal to 1.5. This is the equation number 3. Now we have the 3 equations, 3 unknowns, and find out the value of I2 because we are interested in the VTH. And for the calculation of VTH, we are interested current in this branch because here this potential, for calculating the potential between the AB, we are interested in this current in the 6 ohm resistance, which is I2. Now use the calculator and find out its current I2. Yes. I am expecting the answers from your side. Yes, anyone? Rishikesh, just unmute yourself. Yes.
Sir, I1 6.3 ampere.
I2
3.6. 3.6. I2 6.
3.6 amperes. Avinash.
Correct.
Correct. Okay.
Yes, sir.
Yeah, yeah. Yes. Okay, fine. If we know the I2, then find out the value of the VTH, that is Thevenin's equivalent voltage, which is modulus of. We are traveling from the B towards A. We are traveling from the B towards A means if we are traveling something like this, negative to positive plus, its resistance is 6 and its current is 3.6. Find out this value, which is the VTH. How much is the VTH? Yes. Anyone?
21.6.
21.6
Yes.
volt is the value of VTH. Is it right? Now, if we know the value of VTH, next we will find out the value of RTH. Is it right? We'll find out the value of RTH. I will write here. Is it right? Now here, for the calculation of RTH, load resistance is removed and all sources are replaced by respective internal resistances. This is right. Now, in this case, this is the current source. This is the voltage source. This voltage source should be replaced by zero internal resistance, and this current source should be replaced by infinite internal resistance. This figure will be something like this. This will be the figure for the calculation of RTH. Is it right? This will be the equivalent figure because this path is replaced by short circuit, which is short circuit. This is LZD, this is LZD, and this path is open circuit, and this is A point and this is the B point. How is this equivalent figure? Anyone? How is the equivalent figure? What is the series and parallel combination in this case? Can anyone able to answer? तेजस्विनी स्क्रीन मिनिमाइज है, दूसरा स्क्रीन कर बगत बस लिए तू. तेजस्विनी चौहान. Yes. Tejaswini?
Yes, sir.
Your screen is minimized.
No,
Whatever I am trying to teach, you are not on that screen.
No, sir. Screen is not minimized.
Okay. What is the next thing? Here, in this case, now look at carefully. These two are in series, 8 plus 2, 10. But for this complete path, this path is parallel. And what is this path? Zero resistance path. And whenever zero resistance path is parallel to any path, in that case, its parallel combination will be zero. This here, its next figure will be something like this. Next figure will be something like this. This is the final figure. This is A, this is B. It is 6 ohm, this resistance. This complete is replaced by 0 resistance. Now this path will become which is of the 4 ohm. That's it. Are you getting me? Now look at carefully. In this case, this path is parallel combination is 0. Now this whole path is of the 4 ohm which I have drawn here. And finally, we can find out its value of the RTH. How much is the RTH? 6 into 4 divided by 6 plus 4. Find out this value. Try to understand about this concept because this short circuit is a parallel to this path. That's why its parallel combination will be 0. Yes. Anyone? How much is the RTH? How much is the RTH? Yes, Saurabh. Ruchira.
0.4.
0.4. How much?
2.4.
2.4. 2.4 ohm is the parallel combination. How much is the Ruchira combination? Correct answer. Ruchira. Tejaswini. Yeah. Rishikesh, correct. How much is the answer? Tejaswini.
2.4.
2.4. Are you able to see the parallel combination? Which is this resistance which I am pointing?
What is
Here just 4 ohm. Okay, fine. Now here in this case, if we know the RTH, finally I will write here. If we know VTH and RTH, complicated network is replaced by Thevenin's equivalent network. What is the final figure? Final figure will be something like this. Reconnect the load resistance which is removed in the first step. This is 2.4 ohm is the value of RTH, and VTH is, how much is the value of VTH? This value, which is 21.6. This is right. This value is 21.6 ohm. This is plus and minus. This is A terminal. This is B terminal. In what value we are interested in the calculation? We are interested in the calculation of current in 5 ohm resistors, which is we have removed in the first step. That I will reconnect, which is the 5 ohm. Therefore, this current, which is IL, is equal to 21.6 divided by 2.4 plus 5. How much is the value of its load current, which is IL in this case? Yes. Sorry.
2.91.
2.91 amperes. Yes, Akash. Unmute yourself. Akash. Yeah.
Correct is 2.91.
2.91 is the correct answer. This value is the value of current flowing through the load resistance by using this particular method.